Lesson 2. Where are and how are tropical storms formed? Tropical storms are localized, very intense low-pressure wind systems forming over tropical oceans and with winds of hurricane force. The strongest tropical storms are called hurricanes, typhoons, or tropical cyclones. The different names all mean the same thing, but are used in different parts of the world. If these huge storms start in the Atlantic, off the coast of West Africa, they are often called hurricanes. They only usually occur within a band from 20 degrees north to 20 degrees south of the equator. They do not happen at all times of the year, but are most common between midsummer and autumn. So for the southern hemisphere, this is between December and April, while in the northern hemisphere, it is between June and October. Those storms whose wind speeds do not reach these higher limits but have wind speeds reaching 60 km an hour are usually called tropical storms. The water must be at least 26.5 degrees Celsius down to at least 50 meters. In the beginning, a disturbance forms in the atmosphere, developing into an area of low atmospheric pressure. Winds begin to move into the center of the storm, sealing from surrounding areas of high air pressure. Warm water heats the air and it rises as it nears the center. The ocean feeds warmth and moisture into developing the storm, providing energy that causes the warm air in the center to rise faster. It condenses high in the atmosphere, creating thunderstorms. If conditions are favorable, a tropical depression develops into a tropical storm, then finally into a hurricane, which is not unlike a giant swirling mass of thunderstorms. As rising air in the storm's center condenses, it produces heat, forcing it to rise even faster. The air is pushed out the top, much like smoke out of a chimney of a fire, and more air has to rush in at the surface to take its place. This kicks the ocean up more, and the storm essentially feeds on itself. Formation can be throttled or thwarted by, among other things, strong winds aloft that shear off a storm's chimney. All pressure systems, including hurricanes, rotate counterclockwise in the northern hemisphere. And here's why. When an area of low atmospheric pressure forms, winds begin to flow towards the center of it near the surface. All the while, the Earth is rotating under the atmosphere. In the northern hemisphere, Earth's spin causes an apparent deflection of wind to the right. This is known as the Coriolis effect, forcing a counterclockwise rotation for all storms in the northern hemisphere. Storms south of the equator rotate clockwise. You can visualize the effect by imagining an old-fashioned record album spinning on a turntable. Suppose you draw a chalk line from the edge of the record to the center while it's spinning. The line will be curved even though your motion is straight. When hurricanes move over cooler northern waters, as while racing towards the United States northeast, they lose strength as the fuel supply cools. Storms also tend to pick up speed as they head north and can reach forward speeds of 55 miles an hour by the time they're near Long Island. This forward speed is added to the internal wind speed on the right side of the storm, and it can take a Category 1 storm and effectively make it a Category 4 in a narrow region. Hurricanes also run out of steam over land. Some people think it's due to friction. That's a myth. The truth is, hurricane loses its fuel, the warm water, when it moves over land. In hours, a Category 4 or 5 storm can weaken to a tropical storm status, but the moisture picked up while offshore can continue to pour down copiously for days. A hurricane over land is robbed not just of heat but moisture source that cuts down its ability to produce thunderstorms near the center. This reduces convection, which also serves to weaken the storm. Studies have found that curious things happen at landfall that are related to friction myth, however. Upon landfall, the top sustained winds, those that last a minute or longer, can drop due to dampening effect caused by rough terrain, bushes, trees and houses. But a corresponding increase in brief gusts sort of makes up for this, danger-wise. The gusts are enhanced by turbulence caused by the rough terrain, bringing faster winds to the surface in bursts that last a few seconds.